So today we'll be talking about Google Earth Engine and running a couple of things and learning hopefully a good amount. Just to start off, if you have any questions, we'll follow the sticky notes. Side is green light, you're good to go. Up top, face towards the ceiling, got a question. Claire Beveridge here is a PhD student in civil and environmental engineering. She studies water and all things watery. And we don't have any GE developers, Google Earth Engine developers on Slack with us today, but they did say that if you have questions, etc., feel free. I can kind of accumulate those and ask them, and I'll also go over other resources where you can ask a bunch of questions and get feedback. So setting some intention here, we'll be going slow in the beginning because it's kind of to go fast. And Catherine Kuhn, who usually teaches this is my first time teaching, so bear with me, has this sort of idea of, going slow, learning the moves, and then you can go fast. And I think of this as deliberate. Shout out to my homeboy, Keanu, love him, let's get started. So where did, oh man, I closed it up. So if everybody wants to go to, I had this open earlier, but it had just closed, we'll navigate. Let me just get to the page real quick. Go to schedule. Here we are. And has everyone gotten their, signed up for Google Earth Engine? Raise your hand if you didn't and you need a moment. Okay, cool. I'm just gonna Slack the same thing, so where is it? Right here. I'll put that right down below so then it's on the top of the feed. So go ahead and sign up for that. It should take a couple minutes. At least when I did it, it took exactly 1 minute for them to respond. We'll start with introduction to Google Earth Engine, so skip that other one. You can refer back to that. It basically goes over JavaScript basics and other sort of basic foundational things, but just to move us along, we'll start here. So starting off, we'll talk about what Google Earth Engine is and what are the strengths and limitations of the platform, striving to understand the power of Google Earth Engine and the basic architecture and philosophy. And I'm not here by any means to be like appraising or, I guess like trying to convince you to use it, but just to show you what it's capable of. So what is Google Earth Engine? Gorlick et al., 2017. Check out this paper, short, sweet, has a lot of good information. Describes this as a cloud-based platform for planetary scale geospatial analysis that brings Google's massive computational capabilities to bear on a variety of high-impact societal issues, including deforestation, drought, disaster, disease, food security, water management, climate monitoring, and environmental protection. Well, that's a lot of things. That's a long list, which I think one thing that I really enjoy about Google Earth Engine is that you have a lot of these data sets to work with and that it does exist on this planetary scale, so you can work anywhere in the world and search for those places. Why use Google Earth Engine? Really, why you use Google Earth Engine is using it for analysis and to go through petabytes of data on the fly. So you're using this cloud-based parallelization, so you're, instead of going from problem to problem, next serially, you're cutting this up and working through independent chunks and allowing them to solve it one problem at a time. This allows you to go through things fast. Reason number one, planetary scale science, we covered that. So kind of what I'll walk through now is these celebrity use cases. And I think that's kind of a good term because if you kind of explore Google Earth Engine's website, what you'll find first are these study cases where people have done some really, really cool things. This first one, Global Forest Watch. These friends, Hansen and all, have taken forests, have looked at forest land cover change globally, and they have these maps, time series, and also static maps that you can look at and upload and play with yourself. And it looks at forest cover change, gain and loss, and just forest canopy cover. I think there's a couple of different bands in there that you might be able to play with as well. And one other cool thing is Google Earth Engine does support putting it outside of just its own GUI. So if you click on this one, this one, Global Forest Watch, it will launch you into its own project. And that's something I think, if you were ever to build a bigger project, you could talk to the developers about. Celebrity case use number 2, global surface water occurrence. So after looking at tree cover, you might be interested in just looking at water. And these are some cool, this is like a global water data set that looks at the change of intensity of surface water occurrence in the world. So in other words, they map the loss and gain of water of global science globally at that scale since 1984. So kind of really cool from a perspective of time and space. Time and space celebrity case use number 3, global travel times. I actually didn't know this existed, and I clicked on it. It's pretty interesting looking at the travel times from one point to another in its closest or nearest urban center. So for all the people interested in sort of more urban use cases, transportation, design, architecture. I know, shout out to the people in the back. I know y'all need a little love back there, so check out that. So reason number 1, we had talked about planetary scale. And then reason 2 is this free cloud processing and built-in functions. What's cool is Google Earth Engine is designed for cloud-based parallelized geospatial data analysis, and it takes care of the infrastructure and parallelization decisions on the back end for you. And those operations are called the server side. So using Google Earth Engine, you use a wide set of functions that are developed specifically for computing Google Earth Engine and apply them over many images simultaneously using Google's computational infrastructure. So you don't have to download it, analyze these individual tiles. And I think this is really kind of the plus to this, to Google Earth Engine as well. I feel like when I started, which wasn't even that long ago, doing just geospatial work, you have to go through NASA's various tunnel ways, try to not get lost, find your tile, try to find one without clouds, download it, realize you had clouds, go back in the tunnels, get lost again. And so I feel like this makes it very accessible and makes it easy to filter through your stack of rasters and kind of find what you need. Reason number 3, massive online public data archive. And again, Google Earth Engine, it hosts multiple petabytes of satellite imagery in the cloud, including all of the Landsat mission and other remote sensing missions represented Sentinel-1, 2, MODIS, and others. In addition, Earth observing images, Google Earth Engine hosts produced data sets in precipitation, population density, topography, land cover, and climate. Over 6,000 scenes are added daily from active satellite missions. A couple bullet points that are here. Table 1 in Gorlick et al. That has a really good summary of the data sets. Mind you, the data sets are also added, so it may not be up to date currently, but Google Earth Engine on the website, they have the descriptions, as well as once we launch the GUI, I'll show you guys where to search for them. But it's super awesome if you're like, I'm really interested in just what Sentinel-2 looks like over this area. Let me just play with this for a second. It cost me 10 minutes of time. that type of thing, I think, is really great, as well as just let me import this and compare Landsat to Sentinel. Let me compare different satellite data to each other. Reason number 4, uploading your own data. So aside from having access to a huge library, you can upload your own raster and vector data to the platform. And you can also recommend data sets to the JavaScript code editor through the help button, which I'll point out because that is literally the most important thing that I'll probably show you today. And you can suggest a data set. Reason number 5, let them take care of version control. Google Earth Engine backs up your code in a Git repository without you thinking about it and without you maybe even knowing about it, but not in a scary way, but in a helpful way. You can share those repositories with other users and view older versions of scripts easily from the code editor. And so that's kind of really nice because, you know, it's backing up, backing up, backing up. Reason number 6, flexible access through APIs. The Google Earth Engine development teams worked really hard to make Google Earth Engine accessible. So they do this through different channels, including this GUI that we'll work through today, using their version of JavaScript. And there's also a Python API, which is available. We won't be going over that today. Today we'll just be concentrating on this first bullet point. Oh, my bad. The second bullet point. But there is also this API that's available. And if people have questions, we can talk about that as well. There's also, so kind of backing up here, this Google Earth Engine Explorer in the first bullet point is good for non-specialists on board, perhaps people that are working in industry or government that want to share it with their coworkers that may not want to dive deeper. That's also a good option as well. Yeah, so training materials. And additionally, if you're still not convinced by these 6 reasons, you can click here for more from the Google Earth Engine team. So how does it work? Within the code editor, you can write commands that are sent as an object to Google for processing in parallel to their cloud. So users can visualize results from Google in their browser side, including objects, charts, maps, statistical results. So this flow chart here kind of explains you have all of these geospatial data sets. You send these requests. They, on the back end, do the storage and computing and results. I will say these, so the algorithm primitives, it's kind of interesting to note that Google Earth Engine runs using JavaScript, but it's also kind of has their version of JavaScript, as well as these primitives that are, I think of them as like concatenated or just like smush together a bunch of functions to make it really easy. They used to, back in the day, have, you know, you had to write out more of the functions, but now they've made a bunch of things where you can kind of use things all at once. And we'll talk about those. For example, like you can use it to calculate like normalized difference, NDVI, or NBI, burn, or NDSI, those things through one function. So wrapping up this section here, the common uses of Google Earth Engine operate on petabytes of imagery using Google's cloud. I think really this storing, sharing your version of the code, I think that's also a big point, is after you make your own version, you can share it with other people and be like, hey, this didn't work. Or you can be like, look at this awesome thing I made. It makes sharing really easy and yeah, period. Importing your own raster and vector data, sharing your data, and exporting your analysis for using in another program. What it's not designed for and not good is also good to note. It's not good for cartography. So if you're trying to make beautiful maps, not the place. but exporting allows you a good option. Heavy-duty vector operations, also not good for, and DIY parallelization. As stated in Gorlick et al. 2017, the price of liberation from these details is that the user is unable to influence them. And you can think about that and talk about that amongst yourselves when you feel philosophical at another moment. So moving quickly onto the second one, if you scroll up and we'll go into the code editor. How's everyone doing? Everyone's still awake? Okay, cool. I'll do less talking in this one and we'll open up things. Actually, I will continue talking, but we'll open up things. Okay, so the questions we'll be answering here, what are the key features of the online code editor? Where can I go for help while learning Google Earth Engine? How do I search for and import data sets? And how do I create, share, and save scripts? So what we'll be doing here is opening up the code editor. And what that is, the code editor is, it has a number of different features of programming environment, and it looks like this. So this is kind of a nice flowchart before we open it up. Not so much flowchart, but a little map. Speaking of map, we have the map of the world right here. You have the code editor, that's where you enter all your codes. These different tabs here, I'll describe once we open it up because it might be a little bit more interesting, but this section is very important, the documents and the asset manager. Here is where you'll see everything run and your task manager, see your tasks running. And up here is where you search for data. So if everybody wants to open up a tab and just type code.earthengine.google.com. Click enter. I'm curious if it might draw up, or people drawing up, either people have used it before it might draw up, or you might have to log in. People good? Raise your hand if you're not. Okay. Okay. So we'll just say here, this is just a comment. This is just a comment. And we'll hit this run button. Shortcut is Control Enter. And did anything happen? Yeah, no, because it's a comment. All right, so then let's try printing something to the console. So say, print something to the console. print hello world. And you'll note that you have this little semicolon at the end. If you don't, it's not a big deal. You'll just see this I right here, or I don't know what that stands for, but it's Google Earth Engine saying, hey, correct that real quick. So Control Enter, and you'll see on your console that whatever you printed, whatever you're entering into the console, it'll end up right here. Or entering into the code editor, it'll have a pop up in the console. So moving down here, we'll look at the saving and sharing scripts. So after you have done amazing and beautiful things within Google Earth Engine, you'll want to start saving your things. So looking right here, I'm trying to open this up a little bit bigger real quick so you can see. Okay, that's not working for me. Okay, so if you click save right here, it'll pop up with a window right here. So actually I'm just gonna save it under my main repository, and I'll just type in the name of this workshop, which is 0 to, what is the name here? Code editor. Name it how you will. And you can also message yourself or save something there, code editor. So then you'll see on your side, off to the side here, mine's within this repository, but you'll see up top, code editor. All right, moving on here. Oh, okay. Should I close out or?
Running now.
Let's see, maybe it closed out. Maybe I should just restart this time.
I think you're still on there. And I'll tab, see if
No tab.
sorry, yeah, still tab. Try it again. You mind if I try one?
Yeah.
Thanks. Oh, where'd it go? Okay. Okay, I don't necessarily want it. There's a few people online, so let's just try launching it again, if that's okay.
Yeah. Click here. Oh, there it is. Is that working now?
Yep.
Okay, cool. Sorry, y'all. Okay, here we are. So, sorry for a little malfunctioning. So continuing with the code editor, one cool thing that you'll want to pay attention to is after you save your script, you can click Get Link. And when I did that, did anyone see something change or see something change on your screen? Yeah, so the URL, when you click Get Link, it changes the URL, and This saves automatically kind of every several minutes or so. But when you click get link, it'll come up with the link, and that's very important if you want to use that to share or use it to with your coworkers, etc., and also in the forum and Google Earth Engine communities to get help. You'll see on these, you can also join shared repositories. So we have one for our Google group here. That's only just to get permissions, but everything that should have been changed. I changed that last night, but that didn't happen. I will change that again. It's the same ones pretty much, but the repositories here that I'll update, you can access those, and those will have all of the same code that we'll go over today in full length, so you can run those if anyone gets lost along the way or wants to refer back to them in the future. So in exploring Google Earth Engine, these data sets, there's a ton of different data sets. I know David Sheen yesterday talked about national land cover, so if I were interested in that, I could, at the top, I could be national land cover. You'll come up with a bunch of different ones. You can click on one of them, the top one, NLCD, and it'll have a description of the data set as well as the dates available, the provider, these tags, and the image collection ID. So that's just one example. So for practice of importing, what we'll do here is just below your hello world, go ahead and type in Landsat 8 collection, bar Landsat 8 collection, and EE image collection. So that's saying to Google Earth Engine's way of saying, I'm grabbing a collection, and it's called Landsat LC08/C01, and I'm going to grab the top of the atmosphere collection right here. You can also copy and paste to make it easier. And underneath that, do print Landsat 8 collection. And then go ahead, Control Enter. Oh. Well, that's not supposed to happen. Wait.
Collection.
This is misspelled. Oh,
Lowercase.
Oh, thank you.
The C.
Thanks, y'all.
Whatever.
My bad. Here we go.
Like case.
Yeah. Yeah. Everyone, spell check yourself. So it's computing, and we get an error. And yeah, of course we get an error, because what did we just try to do? Grab all of Landsat 8 at one time. That's not good. Okay, I'll move a little quicker since we hit some errors here. So looking at these geometry tools, so one thing down here you'll see on the map here is being able to move around the map here. You'll also be able to add a marker, so add a point, draw a line, polygon, or a rectangle. And what we'll do now is we'll go to a specific area and use that geometry tool. So just at the top, type in Lake Powell, Arizona. And what this will do is it'll bring you to this map here. You can look at a map, you can look at it in satellite, and you'll take this cursor and take one of these cursors. What is that? Toggle to the map, and it wants us to add 1 point over here. Sorry, I'm reminding myself exactly what happened here. So down at Lake Powell, just add a point right here. Let's take geometry, add a point. And now you've added a point to your collection. And now, since before we had a whole huge collection and now we added a point, now we're able to say, okay, I just want to look at one area and maybe this will make it a little bit easier. So down using this rip, we'll be able to filter it to that point. So just go ahead and you can grab all of this if you want. Make it a little bit easier here. So what we're doing here, is it difficult to see all of the script when I split the screen like this? Or is it okay? Yeah. I will try to fit both of them. It's a little difficult. So what we're doing here is we're making one image from this whole collection that we assigned before. And we're filtering it to these bounds, to Lake Powell, filtering it to this date, and grabbing just these bands and sorting the cloud cover, and then grabbing the first image of the scene that is least cloudy. And I noticed here, I'm like, ooh, Lake Powell, wait, what did I name that before? So when you scroll up here, where you added that geometry, where you added that point, just change that to Lake Powell. So now, let's just click Control Enter. Aha, one more time. What did I misspelled this as well. Excuse me, I didn't want that. This is also a good example of when you want to comment something out, use 2 double slashes. So I made this variable image, so let me just print this image that I filtered out. And let me call it Lake Powell L8 image. Control Enter. So I just printed the image right here, and I'll see on this right-hand side, if I open this up, I'll see, okay, that's good. I got an image. I have this ID falling to this row, path, and month. I have these bands that I asked it to filter out, and it has these different properties that I can look through. I asked for the least cloudy and give me the first one of the stack. So that looks good. The cloud cover 0. So all the things that I asked for looks like it was there. But still, where is my image? So below that, the function to add something to the console is map.addLayer. And I'll call to that image. And I put these curly cues here for now. Those are the image parameters. So that's where you'd be able to adjust kind of what it appears to look like, the bands you want to select, as well as the color, the stretch, etc. And then I'll call this L8 image. And then I'll add the semicolon at the end. And then run or Control Enter. And you'll see something pop up right here. So that's looking pretty good, but you know, it's pretty dark. I'm not really with that. So one thing that you can do when you're trying to adjust how it's visualized is within the GUI, you can click on this gear bar, and it'll show up here the bands you want, the order that you want, you know, the range or the stretch that you want to do. But what's easier, or just another way to do it, is to just type that out. So below that, we'll select the bands we want and the stretch that we want, and we'll call that better L8 image. So I was lazy and I just copy and pasted that. Within those curly cues, you'll call those bands 4, 3, 2, and the stretch that you want. And we'll just run that. So that's looking better. So we'll have, you'll see if you put your mouse over the layers bar in the GUI, you'll see L8 image and better L8 image. This one's stacked on top of that one. So you'll see sort of the one that you didn't visualize or change the visualizations. And that one has the visualization parameters changed. So is everyone kind of with that right now? Are we good? Has anybody got questions? Okay, cool, cool. So scrolling down, we'll skip this stop and play because what we'll do is we'll cover one more of these lessons, and then there's 3 lessons that go through a bunch of different things like classifications or time series, and I'll just let you all loose after we cover that, so then everyone can kind of choose what they're interested in, and then Claire and I will float around and talk to people. But one thing I want to point out here is this getting help, and like I said, this is the most important thing that I will show you today. So several things where you can get help is one, this scripts tab, this documentation tab next to the script tabs, excuse me. Right here, this documentation tab is basically, it's like Stack Exchange inside of Google Earth Engine. So if I wanted to do normalized difference, I could look that up, normalized difference, and it'll tell me what this does, computes the normalized difference between bands, and it'll tell me the inputs and sort of all the arguments that you need inside and what it returns. So that has everything that you need to search for pretty much in there. Very, very helpful. The second thing is this help forum. And within right here, you'll see under the question mark, this user guide has a bunch of information, basically everything that you want to begin and start with images, the image collection, geometry features, etc., is all in here. And it has, if you click on any of them, they'll show you examples of how to do things. And this is super helpful when you're first starting out. The other thing with this help is you'll see this developer's Q&A site and discussion group. And this discussion group, I highly encourage people to join. I've joined under another email, so I'm going to close this out. But it has a huge, long forum of where people ask questions. Post your questions there. Miraculously, the developers do respond and thoroughly. So it's super, super helpful, as well as like cruise around for inspiration. Very good place. Ooh. And when you're sharing your scripts, I also recommend where people one use this get link to share your link to whatever you've written. That will save it and share your work. And then if you're using a certain image, using that image ID to share that with as well. So one thing that a lot of people are often interested in is importing and exporting their own assets as well. So within here on the same tab right next to the Documents tab, you'll see assets, and you'll see I've imported a bunch of different assets that are very clearly organized. That was sarcastic, but that's a way that you can import these, and there are sort of limits to how much the size that you can import. I can't remember it off the top of my brain, but we can also talk about that if you want to on the side. And there's different formats that you can use as well. So that's a very useful place, and I'd encourage if people want to play with that in episode 6 in the time series, that goes over that some more. So we will move on to episode 3, load imagery. How are we doing on time? We're running a little bit late, huh? I have until 12. Okay. So what we'll do now is we'll go in and we'll load a shapefile, and we'll filter an image collection and mask the clouds and calculate an index. So these questions we'll answer today is looking at regional scales of satellite imagery. How can I make image mosaics? How can I use vector data? And how can I export the images? So kind of a lot of the stuff that we covered yesterday with raster imagery, but doing it within Google Earth Engine. So kind of a quick overview of looking at satellite imagery at regional scales. Here we have a figure looking at Landsat scenes all over the US. And are people familiar with Landsat? Yes, yes, no, any. It's kind of the workhorse of remote sensing, I like to think of. Passes through every 16 days and gives us a global coverage. So it's something we like to work with. So in here, we'll be loading a couple different things. First, we'll start out with going here and looking at the watersheds that we want to grab. So we'll be going through and grabbing a vector boundary. And there's different ways to get vector data in Google Earth Engine. First is you can upload the shapefile in that asset folder that I pointed out. And you can create subfolders in there to share permissions with people. That's helpful when you're going through with the forum. You can also import using Google Fusion tables or create your own Fusion tables. And you know, Google Fusion tables is kind of like Google Sheets with shapefiles. So if people want to use that, that's also helpful. And then using existing vector data that's in Google Earth Engine, as well as you can draw points and lines and polygons, which is very helpful if you're like looking at a large collection and wanting just to test something out on a small point. So today we'll be using this USGS watershed boundaries, Hug 12. So I'm just going to start a new sheet here. I will do that properly by doing scripts. You can go to scripts and you can click on new and you can do file. And I'm just gonna add this as 03, what is the name of this lesson? Accessing imagery, satellite imagery. I'll just do SAT-IM. Where did it go? That did not help me.
To your class, like your final to your.
Did it go in here?
The one above it.
Oh, my bad. Sorry. How did it get in there? All right, save your other changes from there, and then we'll have a new sheet. Thanks, Claire. So we'll load these polygons in here, and I'm just going to copy and paste this into here. And what we're doing here is we're grabbing, we're calling to this feature collection water boundaries. And this is the same thing as if I copied and pasted this really quick, just as an example, just to show. This is the same thing as if I went into here and I wanted a little background information. This tells me everything about it. And I want to print from this feature collection just five. And I want to add those watersheds to my map. And I'll do Control-Enter to print that. And if I zoom out, if you're still over leaf vining and you zoom out, okay, zoom out, or you really zoom out, you'll see HUC 12 watersheds over the US. So one thing to point out now is there's a lot of different buttons in Google Earth Engine, so I kind of encourage you to explore those and get familiar with that. It takes a little time, but if you click your mouse and drag and you'll click on this inspector tool right here, these crossbars, you'll see these crossbars. You can click on somewhere in the map and it'll show up here as the feature collection, the watersheds that you called to. It'll have the feature, the ID, and other information, and you can sort of move around there and see those different properties. So we're gonna look at a certain watershed, Republican, and I believe this is the watershed that Catherine Kuhn grew up by, who is a friend of ours and teaches this normally. So we'll bring that into here. So go ahead underneath that, click enter. I'm just gonna copy and paste this in here. So we're calling to this variable watershed, we're grabbing from the original feature collection and filtering that metadata by the name Republican to call to that watershed. And then we're gonna add that to the map, and we're gonna center it on that watershed at a zoom level of 7. So here we are in Kansas, and we have this watershed outlined here of Republican. So that's pretty cool. So now that we have a place in mind, now we can bring some data in. Today we'll be working with the Landsat 8 surface reflection collection and looking at that watershed over a year. So again, you can either type this out, or I'm just gonna put this in here and we can walk through it real quick. What is it not liking here? Okay, so now we have this place, we're loading in the Landsat 8 image collection, and we're filtering it to that watershed for the date. And we can print that and see, it'll show up with what we had before. And then on this right-hand side, we see this little console popping up that's yellow marked. That shows that it has what we requested is being delivered. So right here, you'll see 276 elements because we just called for the last year. So it's gonna show us all of these different features. So these are all the images that you'll get of Landsat over this past year that you filtered. So if you change the date to another, get a smaller one, of course. So that's kind of cool because you know, I think in a lot of other ways, you can do this in like through a portal or through, as we did in the example yesterday, but it's kind of fun that you can do this in just a couple lines of code. So now mapping functions, we'll add this, you can see, just, I'm just going to read this section really quick because I think it's important. Mapping functions, as you can see, browsing the Documents tab, there's Google Earth Engine specific functions to both image and image collection data types. And there are a lot, including mathematical and Boolean operators, convolutions, and focal statistics, spectral transformations, and analyses of spatial texture. Browse the list or read about general operations in the developer's guide over image overview section. Often we want to use the function over each image in the image collection. And to do so, essentially, we're looping through the image, each image in the collection, and Google Earth Engine loops to accomplish this through the map function. Avoid actual loops at all costs. And so I want to emphasize because Google Earth Engine does not like for loops. It uses this dot map parentheses function to do the for loops. So you don't have to write those out yourself. Using this image collection.map is the good way to do it. So we'll try that. So now that we have that one section, we can mask out the clouds. So what we will make use of is this Pixel QA band, cloud band provided by the SR products. And this allows us to mask out the clouds in the image that we're looking at. So we'll define a new function called mask clouds here, and we apply it to that image collection with that .map function. And that will return our final output. So again, I'm just going to copy and paste this real quick so that we can see it through. And I know it's a lot of copying and pasting, and I know when I'm going through them, I'm like, I actually want to write this out so I can understand, but just know that it's all here and you can go back to it. So here we have this, we're writing this function, mask clouds. We're calling to this, we're calling this variable pixel QA, and we're selecting this band within this image pixel QA. And we want it to update as a mask to the image the pixels that are clear 0 or 1. And in the QA, I'm sure if you search for the QA, that's equal to a value of 322. What we'll do then is we'll use map to apply the function, and that maps it over the collection, goes through that loop. We assign these image parameters to call out the bands, and we're gonna ask for just the first image. And this is kind of a good function to know too, is calling to that first one, because otherwise you'll get a big stack. And we'll make another one that is original. So we'll have 2 images, one that is masked and one that's original. And so you click over the layers again, you'll see your watersheds. And then let me load the ones that are clouds that are masked. And it's showing up blank because we're looking at the summer, should change, and the original. So that's the original, and then where the clouds are masked. So it masks it all. Yay. Change the dates and you'll see some other magic. So I think I heard some other groups talking about doing some indexes around burning. This might be an interesting thing to explore, other people that are interested in vegetation. But one thing that Google Earth Engine has done is this cool function of normalized difference, and they've done a bunch of different operations similar to this. Here's a guide that describes more of that. So here we'll calculate an NDVI over this area. And I will just grab all this and we can look at this really quick. Okay, so just following along here, we're going to run this function similarly to the other one of mapping it again. And we're going to use this normalized difference function and rename it NDVI. And you can also do this, and I'm going to take this out right here as an extra to just run that manually versus using this function. So we'll map that over and then we'll get the first one. And what you'll see in the console here is that image right there. And does it say here to grab the one? Okay. So here we'll have all the information on the right-hand side of the NDVI that we just calculated, we'll be using. But what if I actually want to look at the greenest pixel composite? So what's also cool is that you can, within Google Earth Engine, you can mosaic there's these mosaic and compositing options. And you can use functions that call for the maximum of the max value of an image collection, as well as looking at the image collection and making a mosaic of it. And here in this example right below, we'll do a quality mosaic. So what this is basically doing is we're taking a stack and we're going from every single pixel and just saying, hey, give me the best pixel of this entire stack, and I'm gonna make a mosaic from it. So the greenest pixel composite. And I will just bring this in here. It's very similar to the other ones that we had here. And since we have a bunch of other stuff above, what I'm just gonna do is comment out this. And this is also a good trick to comment out a big old chunk, is just select a bunch of it and then control / and I'll bring it back down here. And then I can go back and just say, all right, I just want to look at my quality mosaic. So, oh, actually, I can't do that because I need a bunch of that. Just checking if everyone's awake. All right, so before we had calculated our NDVI and we wanted just the quality pixels from it, the greenest ones. So I'm gonna do quality mosaic, this function, and I'm gonna clip it to that watershed that we need. Then you can assign this NDVI palette, and this is similar to what we had looked at here in this little section with this bar. You can assign its own color palette, and there's some really cool ones online that the developers have made that I can share with you as well. Some pretty colors. And then you're gonna add that to the map, and I'll just do Control-Enter. Cool. So you can see over this watershed, this mosaic of NDVI, you got some greener areas here than others. Let's just see what that looks like in comparison to, curious what that looks like in the world. So I'm just gonna click on satellite. And this works similarly to, a QGIS or ArcMap program, where you can switch this off here and kind of look at the transparency and kind of examine different areas. So you can do that. You can click over here and look at the watersheds over it, etc. And if I want to look at the true color composite, which is similar to what I just pulled up with the satellite image, you can map, and we'll do a composite using just the true color bands, and Control-Enter to see that. And we'll see over here, these layers, we'll add both of them. I can change this, so click it on. And you'll see the true color composite pop up. And if I wanted to look at the NDVI and I wanted to sort of stack these, kind of play with this to better understand that area, then you can do that as well. So one really cool thing, I feel like I keep on saying cool thing because I feel like I often think that when I find new things within Google Earth Engine, I'm like, oh, that's a cool thing. So, but another useful addition is visualizing data within a chart in Google Earth Engine. The limitation is you won't be able to have as much freedom, I think, to play around with it if you're to do that in Python or another other program, but it is a really quick and easy way to map out an area and then create like a time series and look at it, and then change the date or change another parameter and see what happens. So here we're just going to use these UI charts, and I'm not sure if this covers later. I think in the other exercises, it'll talk about these UIs. So before we jump straight, do that, I want to just divert and look at these under the scripts tabs, this examples. And under examples, there's all of these really, really cool examples of images, image collections, etc. And they have ones on these UI charts that I'd encourage people to look at. They're really fun. But let's go and make a chart for NDVI over our area. So I'm just going to grab this first part where you're creating a chart and printing it. Open my window a little bigger. And so we'll create a chart from the time series that we were looking at before for 1 year. We'll look at it over the watershed, and we'll reduce it using this mean. And reducing, there's all this documentation on how reducers work in Google Earth Engine. We're going to be using the average. You can also do max, min, etc. And we'll scale it to 250. So you'll see what you had before, your whole chart, and then now, as it's generating on my computer, perhaps you may already have had it, but slowly. Okay. I'll let that generate because I'm pretty sure there's another one, an example right here. So while my computer is thinking, it looks like this. You'll have, you'll pop up with a chart that looks like this. It has the band, the mean NDVI over time. You'll see a peak in the summertime and a decline elsewhere. So that makes sense. And there mine pops up over there. So one other thing that you can do after you have, you've calculated and you've brought in a shapefile, you've filtered the image collection, you've calculated the NDVI, and you've made a chart looking at that, and you now can export that. I'm gonna not do this part so I can send you guys off into the next exercises, but if you want to copy and paste this whole part and run that, basically what you're doing is then you can export what you've done to a table, a CSV table, and then you'll be able to bring that into another program and work with it. And I would highly encourage, Google Earth Engine is great for grabbing the data set really quick, looking at it, and running some quick stats on it over either a short amount of time or a small area. But if you're trying to do that over a big area or for a really long time, I'd highly encourage exporting that and then working with it elsewhere. Yeah, and then similarly, you can export these using these functions of export image to drive. And there's some other functions to export it in different formats, etc. Refer to this Documents tab, or also to this user guide. So at this point, I'm gonna go back to these episodes right here, this home of Google Earth Engine, and what you'll see is temporal spatial reducers, supervised classification, and time series. So for the next 15 minutes, I'll let y'all kind of go loose and go into one of those. Maybe you all can split up, either go individually or you can work with a partner at your table. And then I'll give it a couple minutes for you all to share at your table what you guys learned.
Thanks for sharing. That was really super helpful. Which is, I guess, like I'm new to all these tools. And when to use like Google Earth Engine versus like QGIS and ArcGIS. Like when to, because these seems like they all just display a map. You can add layers, you can do some calculations like NDVI. So what would you say is
the difference?
Yeah.
I feel like the difference that I see for QGIS and Google Earth Engine is if you have the data already or not. Like, I think that's a big one because it takes a lot of time to download.
Yeah.
And so if you don't want to
manage storage and everything.
Yeah, exactly. Like that's its own other task, right? So if you just want to use, that's a great way to use Google Earth Engine. I feel like there are differences, like it's projected, the projection that it's used
is the Web
Mercator, like grade 5.7 or something like that.
So you can't, okay, so one thing you cannot do in Google Earth Engine is reprojecting.
You can, it's a little bit complicated. So like they have documentation.
Okay. So what would be something, so I guess like Google Earth Engine, it just like brings in data from like Google storage and QGIS or things like that, you have to provide your own data. So like when would be a use case where you have to not be able to use Google Earth Engine?
Yeah, I would say if you're trying to, one, like make any sort of pretty map, two, trying to project in another projection, three, if you want to work with a data set that's not available in Google Earth Engine,
you can also
then
upload
if you're uploading like a small data set, awesome. Or if you have like a huge data set, like Joe was saying, he's like, oh, I want to upload. Joe, somebody was saying like, I want to upload like 4 terabytes of stuff. So you have to then, I think, contact them and ask them.
Right. And okay. So it just seems like such a convenient tool. Like everything you just said was like super intuitive, whereas I find myself going through like ArcGIS tutorials and was a lot more complicated.
Yeah. And I think also maybe another thing to not use it for is like doing stats.
Okay.
You can do like you can graph a bunch of stuff, but as you saw, that was on mine, like it took a second just to
draw the NTVI over time.
Yeah, but that's also like a year, right?
Yeah.
I just did that very quickly in a couple lines.
Yeah.
Quickly, this last episode of the Google Earth Engine lesson. So some closing thoughts. We covered these first ones of introduction, the code editor, accessing satellite imagery, and y'all went through these last 3. I'll let you all loose, because I'm curious of what everyone thought and what people's experiences were. So we can walk around and talk about those. But before then, bookmark a couple web pages to bookmark and just save. This is the code editor where you all were coding. The data catalog is really awesome to have data sets. This developer's guide, keep this close. It's your Bible. This developers forum is where I spend a lot of time. Go there, use that resource. It's just as important as this guide. Additionally, these learning resources, there's Google Earth Engine tutorials that you can click on, and as well as this education page. So there are plenty of materials online to support what you want to do. This debugging guide also, if you want to go even further, is kind of the FAQs, I think, of Google Earth Engine. And so that's also a really great place to look. This Under the Hood forum is something where you may inevitably begin to have questions. Wait, you may end up there, is how I think of it, if your answers are not answered. And lastly, this paper with Gorlick et al. Is also a great place to kind of refer back and see what their intentions were with creating this and where they want to go. Another thing too, I will add with the developers forum, they have like updates with data sets as well as like updates of events. They have summits that happen globally and also annually, I think in Mountain View, California. So look for when that comes out. I think the one in California usually comes out, the announcement around April, but that's supposed to be really great as a way to kind of build that community and see what people are working on as well as share your work. So with that, in the last 3 minutes, hello, Keanu. We'll all stand up and we'll have go through 3 questions. 1, what are 3 things that you learned in this tutorial? 2, what are 2 ways that this connects to other tutorials you've seen? And what's 1 way you might be able to apply this to your research? Or what's 1 question that you have about Google Earth Engine? So yes, in the last 3 minutes, choose one of these questions, talk to people, and then go have lunch. Thanks, y'all.